So my name is Petri Ekholm and I work at the Finnish Environment Institute. I'm kind of phosphorus scientist, but I have very much worked lately with the gypsum amendment of agricultural fields. Thank you very much for giving me the opportunity to tell about gypsum's role as a soil nutrition and in reducing phosphorus runoff. And much of the presentation is derived from the GYPREC projects which I lead. I will briefly tell you about Finnish experiences on gypsum amendment, and we highlight the fact that it's mainly a water protection measure in Finland. Then I look a little bit farmers' perspective, then tell you something about the GYPREC project, where the question is, could gypsum work elsewhere than in Finland? And then a little bit about Nord Gypsum project, why gypsum works or doesn't work. And if time allows, I will show you one animation at the end of the presentation. So gypsum is no news in the world. For example, Benjamin Franklin used it in the 1800s in USA, and the first history of the use of agricultural gypsum was published 100 years ago. But what is quite new is that gypsum is used as a water protection measure. And now I go to the gypsum amendment and the Finnish experiences. I tried to do a fancy slide. I don't know whether I managed to do it. And we put a hint of gypsum on the surface of a field to be about 4,000 kilograms per hectare. And what happens, at least in southern Finland, we get the turbid ponds, turbid surface runoff, turbid drainage water. It transforms into almost miraculously clear water, at least for some time. And if we go to a little bit more details, we have calculated that as a phosphorus reduction measure. It's perhaps the most cost-effective ones we apply in Finland. It reduces the losses of particulate phosphorus, meaning phosphorus bound to eroded soil particles. It reduces dissolved phosphorus, which is more eutrophying than the particulate phosphorus. And as a bonus effect, it also reduces dissolved organic carbon. The effect is immediate because gypsum is quite soluble, taking into account that it is a calcium salt. But as it is soluble, it also be flushed away so that the effect lasts, depending on the study, from less than 3 to more than 5 years. It doesn't treat the root causes of agricultural loading, but perhaps it gives times for addressing them. And in Finland, at least, there are quite large amount of suitable field areas. Fine textured soils, clay soils are perfect, but also other soils may react to gypsum. And the evidence has been so strong in gypsum in Finland that there is now a gypsum project in Finnish language, GYPSI, where gypsum is given free for farmers on certain target areas. And now about 80,000 hectares have been treated since 2020 with gypsum. I don't know exactly, but I think that it is close to what are the acreages of structure liming in Sweden. So what is then gypsum? The title also already says that it is calcium sulfate and 2 crystalline waters. And there is a lot of gypsum in the world. For example, in the Baltic countries, we have many phosphogypsum stacks, but not all of them are utilizable because only magmatic apatite is free from cadmium and radioactivity. And for example, in Finland, the Siilinjärvi mine is such contains so-called good apatite, whereas Uusikaupunki mine doesn't contain such. Then we have flue gas desulfurization gypsum. I give here an example from Poland. Latvia is full of natural gypsum, which is mined there. And then there is industrial byproduct gypsum and finally recycled gypsum. Here you can see the apatite mine in Siilinjärvi, where apatite is transformed into orthophosphoric acid and the byproduct is gypsum. there is almost a mountain there in that district, and they call it the Alps or the area. They are a really high mountain or gypsum, and then a smaller heap on a field ready to be spread to the surface of the field. You cannot use gypsum elsewhere, even in Finland. It cannot be used in winter because phosphogypsum contains a little phosphorus, and if the gypsum doesn't have any contact to soil, it will then be flushed by snowmelt water to receiving waters with the phosphorus in gypsum. EU regulations prohibit use of any other than mined gypsum in organic farms. And then very important is that gypsum shouldn't be at least massively used in catchments upstream of lakes, because sulfate may accelerate eutrophication of lakes and reservoirs. Then there are some other potential restrictions. If the soil is low in magnesium or potassium due to cation exchange reactions, it may become even lower even poorer in these cations. So you should look at the agronomical soil tests whether gypsum is good or not. In Finland, we don't use it in groundwater areas. We have very strict groundwater legislation, but on the other hand, moderate increase in sulfate is quite harmless to humans and structures. Then there are certain salt-sensitive plants, some berries and vegetables where you can consider whether to use or not. And then selenium crops decreases at first, and it has to be taken into account if the crops are used for feeding animals. Well, from the farmer's perspective, in general, I would say that there's no negative effect on the quality or quantity of yield. Instead, there's a lot of calcium and sulfur. The standard dose 4,000 kilograms per hectare of gypsum contains 800 kilograms of calcium. And I'm not an agronomist, but I have understood that calcium prevents stem rot and potato scab. And for example, potato farmers don't like to use calcium carbonate because it increases the pH and then may induce that scab. Then there's 640 kilograms per hectare of sulfur, which is very well taken by cruciferous plants. And as I said, phosphogypsum contains some phosphorus. We haven't found any harmful effects on plants, whereas soil quality and tilling workability of the soil may improve. Gypsum suits most farming practices, no special equipment is needed, and when we have interviewed farmers in Finland, the attitudes have been varied from practically neutral to somewhat positive. This is the water protection angle, but then most gypsum in agriculture in the world is used to reduce subsurface acidity and aluminium toxicity and to improve soil structure in sodic soils. And there are also other purposes of using gypsum in agriculture. Here is a table where we studied surface layer of mineral soils receiving gypsum or not receiving gypsum. And we studied what happened before, after 1, after 2, and after 4 winters in the soil itself. And what we found out is that pH decreases when it has been determined in water extraction, a little in the first year. Electrical conductivity increases for 2 years as well as does sulfur, but no other changes. And the same goes with plants. We only found an increase in sulfur, no other changes. Well, it seems that gypsum works in Finland as a phosphorus reduction measure, but could it also be applied elsewhere? And that's why we have this Interact project called GYPREC, where Latvian Research Center for Agriculture and Forestry, Lithuanian Research Center for Agriculture and Forestry is included. Also, the name of the GYPREC project is Tackling Agricultural Phosphorus Load by Soil Amendments, and here you can see our partners, and in addition to this GYPREC, we also have Nord Gypsum projects where we take aboard Norway and Denmark. And the overall aim of the GYPREC project is to construct a validated national operating model for gypsum application. And it contains a lot of aspects, but it responds, for example, to the HELCOM's kind of recommendation that till 2027 we should take into action those measures in agriculture which improve soil structure and aggregate stability, such as lime, structure lime, and gypsum. Now I wonder whether it... Here you can see a small snippet how gypsum has been spread in Åland Island. This is a little bit dull video. It just goes on and on and on, but here you can see white powder spread on the fields. And here you can see how we have tested it in one laboratory, how it might affect the leaching waters under artificial rainfall. Here are Swedish and soil samples taken from Åland. And I took the liberty to show you some results created by Danute and others in your research institute. Here you can see what happens to phosphorus concentration in leachates from pot experiments. On the left side, you can see 3 watering events control the phosphorus concentrations and the deviations in the controls. Phosphogypsum from Lithuania clearly decreases the phosphorus concentration. Phosphogypsum from Finland reduces too, but not so much than Lithuania, which is very interesting as such. And construction gypsum seems to work quite well too. But it didn't work in all the Lithuanian soils, and it hasn't been working in all soils from the other countries either. And right now we are collecting information and trying to explain why gypsum works somewhere but doesn't work elsewhere. But Lithuanian research also found out that if we read this last sentence, these findings highlight the potential of gypsum, particularly phosphogypsum, in improving nutrient retention and crop development in acidic low clay soils, which I guess are common in Lithuania and Poland too. So we get a lot of results from GYPREC project, but also from Nord Gypsum project. And here you can see what happens to mean dispersed clay amount in 3 Danish soils. And we try to find some simple laboratory experiments where we could mimic the effect of gypsum. And one might be this clay dispersion test. And here you can see that in the Askov soil, which is on the left, there is a clear effect of gypsum, but then in the other soils, there isn't such a clear effect. These are being done with cooperation with Aarhus University, and we are writing a paper on this right now. Well, here is a table of phosphorus load to the Baltic Sea from certain countries. I have to say that these are from 2015, which was a quite dry year, so it's not the actual loadings may be a little bit higher. In the middle column, there is the field area, and then the potentially gypsum eligible fields in square kilometers. No, in hectares, sorry, in each country. And as you can see, Poland has a lot of fields, but it has also potentially gypsum eligible fields quite a lot, as does Lithuania. On the other hand, Sweden has quite little, and outside this table, Norway has none. So it depends on the geography also how potential gypsum amendment is. And here I mean that some countries are built so that there are so much lakes that you don't find any upstream, any field area which discharges directly to the Baltic Sea, not to a lake first. Then I made a list of publications published in the Baltic Sea air countries about gypsum. There's a lot of them and more is coming. And if I have time, I show the one video.
Baltijos jūros pakrančių vanduo yra stipriai eutrofikuotas dėl taršos azotu ir fosforu. Didžioji dalis fosforo į Baltijos jūrą patenka iš žemės ūkio. Žemės ūkio veiklos sukeltą eutrofikaciją galima sumažinti įnešant į dirvožemį gipsą, hidratuotą kalcio sulfatą, kuris drėgname dirvožemyje tirpsta skildamas į kalcio ir sulfato jonus. Ištirpę jonai padidina druskų koncentraciją gruntiniame vandenyje. Dirvožemyje molio detalės yra mikroskopinio dydžio, turinčios neigiamą krūvį, todėl jos gali prisijungti teigiamai į elektrintus jonus, kationus. Kartu neigiami ir teigiami krūviai sudaro dvigubą elektrinį sluoksnį, kuris išlaiko daleles atskiras vieną nuo kitos. Druskų poveikyje elektrinis dvigubas sluoksnis susitraukia, todėl molio detalės gali suartėti ir sudaryti mikrotrupinėlius sujungtus vienas su kitu kalcio jonais. Dirvožemio mikrotrupinėliai netaip lengvai nuplaunami su lietaus ir tirpstančio sniego vandeniu. Padidėjęs druskos kiekis taip pat pagerina fosforo jungimąsi su dirvožemio dalelėmis, to pasekoje sumažėja fosforo įsiplovimas, tačiau augalams jis išlieka prieinamas. Tokiu atveju drenažo vanduo tampa skaidresnis ir sumažėja su dirvožemio dalelėmis susijungusio fosforo įsiplovimas. Gipso įnešimas į dirvožemį sumažina ne tik fosforo, bet ir organinės anglies įsiplovimą. Šiame projekte nagrinėjimas gipso tinkamumas Baltijos jūros regiono valstybėse.
So, thank you very much for your attention.